Now that we've talked about independent and dependent events, we're going to move into mutually exclusive and non-mutually exclusive. Right? So independent and dependent events happen, or we use those formulas whenever we had two events happening. So we were rolling a die twice, or we were picking two different cards. Mutually exclusive and non-mutually exclusive comes from one event. So now we're looking at the or. We're looking at this or this happening in one time, right? Or getting a red card and a king at the same time, but it's still just drawing one card, one event is happening. So to begin with, we've got mutually exclusive. When two events have no outcomes in common, they are mutually exclusive. These events cannot occur at the same time. So our Venn diagram for mutually exclusive events would be two separate circles. They have no overlap. They do not have a both. There is no and. All right, so whenever you have two different things that have nothing in common, all we do to find the probability is add them. So for the first example, a fair six-sided die is rolled. What is the probability of rolling a number less than 3 or rolling a 5? So my numbers that are less than 3 are just 1 and 2, and then rolling a 5. So there's no way I can get a number less than 3 and 5, so that's why these are mutually exclusive. So rolling a number less than 3, that's 2 options out of my 6. And then I've got to add getting a 5, which is 1 option out of 6. And when I add those together, I get 3 out of 6, which is just 1/2. Right? That's the same thing as if I just listed all my possible outcomes. So if I am rolling a die, I can get 1 through 6 as an outcome. And then here's my numbers that are less than 2. Here's my 5. So getting any of those would be 3 out of 6 or 1/2. For the second one, we have a card drawn at random. We want to find the probability that the card is, first, a king or a queen. There's no way I'm going to get a king and a queen at the same time, so these are mutually exclusive. So a king or a queen would become 4 out of 52 plus 4 out of 52, right? I have 4 kings, 4 queens, so we get 8 out of 52, which we can keep simplifying, 4 out of 26, and 2 out of 13. Right, so that's my probability. The probability of getting a king and a queen, right? I cannot get a king and a queen at the same time, so the probability of that happening is 0. That is a property of mutually exclusive events. If I go back to that first one, right, here's my rule that we just talked about. All we do is add, and then a property of mutually exclusive events is that there isn't an and. So the probability of getting A and B will always be 0. For the third one, Jack is shopping for a new snowmobile. The probability that someone buys an Arctic Cat is 39%, a Polaris is 27%, and a Ski-Doo is 18%. What is the probability that the person buys either an Arctic Cat or a Ski-Doo? All right, remember, just a good habit is to not use parentheses whenever we're plugging in our formula. So we're going to put them in decimals. So 39% is 0.39, Polaris is 0.27, and Ski-Doo is 0.18. Right? So another probability that a person buys an Arctic Cat or a Ski-Doo. Well, they're only buying one. He's not going to buy both of them, so they're mutually exclusive. Getting an Arctic Cat is 0.39. I'm going to add that to getting a Ski-Doo, which is 0.18. And then 0.39 plus 0.18 is 0.57. And you can leave that as 0.57, or we could put it back in percents at 57%. A fair die is rolled. What is the probability that it lands on a multiple of 2 or on a 5? Okay, well 5 is not a multiple of 2, so we can't get both of those at the same time. Multiples of 2 would be 2, 4, and 6, so that's 3 out of my 6 options. Then I'm going to add getting the 5. 5 is 1 out of 6, so 3 plus 1 is 4. 4 over 6 simplifies to 2/3. Two standard dice are rolled. What is the probability that the sum of the numbers on the dice is equal to 6? So technically here we have mutually exclusive events. Oops, go away. Because in order to get the sum to equal 6, right, my options are 1 through 5, so I can have 1 and 5 together. I can have 2 and 4 together, and then I can have 2 3s. Those are all of my options to getting a sum of 6. All right. Now the trick comes in is because I can have a 1 first, then a 5, or I can have a 5 and then a 1. A 2 and a 4 and a 2, and then a 3 first, a 3 on the second one, or vice versa. Okay, so I have a bunch of options here. So remember, anytime we're rolling 2 dice and we're looking at the sums, we're just going to make a table, the same table every time. So across the top, I'm going to have 1 through 6. And down the side, I'm going to have 1 through 6. And then I'm going to fill in my sums. And remember, there is a pattern. 1 plus 1 is 2. And then we go up by 1 each time. And the same thing going down the side. And then we start with 4 and go across. And same thing going down the side. And so on until you fill in your table. Alright, so now I'm looking for a sum of 6. Well, all of my 6's are right down here. So to get a sum of 6, that's 5 options out of my total number of options, which is 36. So the probability of getting a sum of 6 is 5 out of 36. So we've got 5 out of 36 for that one. Alright. Oops, next one. Non-mutually exclusive. So now our two events have something in common. Okay, they are non-mutually exclusive and they can occur at the same time. So non-mutually exclusive events are going to have an overlap because you can get that both. Right? Now the problem with having that overlap is if I have used my other formula of just adding my probabilities, if I add in the A plus the B, I end up counting that overlap in the middle, the section here, I end up counting that twice, right? Because I included it with A and I included it with B. So the way that we get around that is we add them together, but then I take out one of those ands. I'm going to subtract out that overlap. So I'm still going to add my probabilities, but just subtract the and. So for our first example, if one card is drawn at random, what is the probability of randomly selecting a 10 or a red card? Well, to get a 10, that's my first probability. That's 4 out of 52. Then I'm going to add in the probability of getting a red card. Well, to get a red card, that's 1/2 or 26 out of 52. And then I'm going to take out the overlap. Well, I have a 10 of hearts and a 10 of diamonds. Both of those are red. So I'm going to take out 2 out of 52. 4 plus 26 is 30. 30 minus 2 is 28. So we have 28 over 52, which we can simplify to 14 over 26, and one more time to 7 over 13. Okay, so make sure when you go to add your fractions that you have the common denominator before you add. This is one where you might not want to simplify until the very end, so that you have that common denominator. For the second one, a fair die is rolled. What's the probability of rolling an odd or a number less than 4? Well, my odds are 1, 3, and 5, and the numbers less than 4 are 1, 2, and 3. So there's some overlap there. These are non-mutually exclusive. So rolling an odd number, that was 3 options out of my 6. And then rolling a number less than 4, 1, 2, and 3, that's 3 options out of 6. If I had stopped here and just added, that would have given me 6 out of 6, which is 100%. I don't have a 100% chance of getting an odd or a number less than 4 because I still have 4 and 6 as an option. Okay, so we can't stop here. We've got to take out that overlap. So the numbers that are odd and less than 4 would be 1 and 3. So that's 2 out of 6. 3 plus 3 is 6, minus 2 is 4. So we get 4 out of 6, which simplifies to 2 over 3. The third one, on a given night in March, the probability that it's going to rain is 60% or 0.6. The chance that it's going to rain and snow is 0.17, and the chance that it's going to snow is 0.32. What is the probability it's going to rain or snow? Right, so we're just going to plug in our formula. First, we have the probability that it's going to rain. Then we're going to add in the probability it's going to snow. Then we're going to take out the probability it's going to rain and snow. So rain is 0.6. And then we're going to add snow, which was 0.32. And then I'm going to take out the overlap, which is 0.17. So 0.6 plus 0.32 is 0.92. And 0.92 minus 0.17 is 0.75. So the chance that it's going to rain or snow at least one time in that given night in March is 75% or 0.17. If one card is pulled from a standard deck, what's the probability that the card is a red card or an ace? This goes back to the first one, right? So for it to be a red card, that's 26 out of 52. An ace is 4 out of 52. But I have the ace of hearts and the ace of diamonds, and we counted those twice. So I have to subtract those two, so they're only in there one time. 26 plus 4 minus 2 gives me 28, which just like earlier we said simplified to 7 over 13. And the last one, if a child tossed a die, what's the probability they roll an odd number or a number greater than 3? Right, so greater than 3 is 4, 5, and 6. That 5 is the overlap, so that's why these are non-mutually exclusive. So my odd numbers, 3 out of 6. Greater than 3, 4, 5, and 6, that's 3 out of 6. And then the odd numbers that are greater than 3 is just 5. So that's going to subtract that one number out of 6. 3 plus 3 minus 1 gives us 5 out of 6. All right, and just to further clarify that one, if I have these options when I roll a die, 1 through 6, right, and I want to roll a number greater than 3, okay, that means it's got to be 4, 5, and 6, okay, or an odd number. Well, my odd numbers are 1, 3, and 5. And remember, whenever we say or, we're not being picky. We want anything that falls in any of those categories. So that leaves us with 5 numbers. But if I just added, this 5 over here was counted twice because I counted it with my odds and with my numbers greater than 3. So I had to add those probabilities together, but then subtract that one overlap so that I didn't count it twice. And that's what it means to be non-mutually exclusive. You have that one event or several things that are in common between your two events.